In order to do this nanotomography, we need very fancy X-rays. And these X-rays are produced in particle accelerator. What we do is to move electrons at the speed of light, and then with magnet, we shake the electron, and they produce very powerful X-ray beam. Then we can, with such a high intensity, we can, let's say, condition this photon in order to do this tomography or diffraction experiments.
At Kadam's, we combine innovation with infrastructure in the heart of Europe's leading science clusters. We understand that the places where research occurs are as critical as the research itself, which is why we reach out to the rockstar scientists to grasp not just what they do, but why they do it. Join us and become part of this story as we take a look behind the science.
My name is Miguel Ángel García Aranda, and I am professor of chemistry at University of Malaga, working in cement sciences. What I enjoy most is to discover tiny things that were not seen before. Now, what I do is to combine this discovery with some application. Let's say we discover this in order, if we are lucky, to bring it to the market or closer to the market. What I really enjoy most is understanding.
So you are using technology and science to reinvent a very traditional industry. Tell me about what you're working on right now.
We are working in lower the CO2 footprint of cement. Cement has been here for the last 2,000 years in different versions, and from 200 years, the Portland cement. So for every ton of Portland cement that we fabricate, we emit about 0.8 ton of CO2, but because we fabricate such a large amount of cement and concrete, this is about 8% of all man-made CO2 emissions. The low carbon cement are in the market already, are out there. However, they have one weakness, which is that they set and harden not fast enough, and we need to remove the formwork. So really my approach is not developing a low carbon cement, but optimizing the low carbon cement that we have in the market in order to accelerate their hydration to be competitive. Because as you can imagine, if the cement today are not competitive, this low carbon cement, they will not enter really in the market at as we wish, which is in very high ratios. But in order to optimize this acceleration and to fully understand the mechanism, we use very sophisticated analytical technique to look inside the sample with very high detail, and in order to improve the performance of this existing low carbon cement, but not competitive as we speak. So in order to analyze this low carbon cement, to understand why they hydrate at this lower speed, we use a combination of techniques, but the most important technique that we are developing in Malaga is to do nanotomography. Nanotomography is the standard tomography that we can do at the hospital when we take a patient and we take different radiography, and then we build a 3D virtual view. But we can do this in our machines like synchrotron, in this particle accelerator that produce very fine X-ray beams with very much precision and detail. And then we can do this very detailed tomography in order to understand this bottleneck, why the cement are hydrating slower.
And nanotomography lets you look across 4 dimensions? Is that how you described it?
Let's say, in addition to do a tomography and nanotomography, that is to take this 3-dimensional view of a cement hydrating, now our contribution is to do with time. Let's say, to take this tomography at time 2 hours and another tomography at time 5 hours, and so on in the first 1 or 2 days. And this is what we name 4D. The 3D comes from the tomography, and the last 4th dimension comes from time, because we have to understand not how the particle dissolves and precipitate, but also how they evolve with time in order to understand these bottlenecks and hopefully to be able to accelerate it in a competitive manner. Time in construction is very important, it's critical, because we have to remove the formworks at a given time. We are used to remove formworks depending upon the construction in 1 or 2 days, and we cannot afford to leave it 3 or 4 days to build new stores and to continue. So time is critical in construction, always keeping safety.
You're based here at the university. What is the ecosystem like? What resources are available that are special for you here?
The university has a broad range of equipment and different collaboration with the informatics and software faculty, but on top of that we have the technological park, and the technological park is the biggest asset that we have, where we can collaborate with other startup companies, institutions. So Malaga has this, let's say, landscape which is brilliant, but on top of that, science is about collaboration, not only collaboration with publicly funded institutions, but also with companies. So, but Malaga is the center of our work.
Can you say more about why technology, software, why is that important for science and innovation here?
Because at the end of the day, we have to process data. And this data, not only with normal standard software, but also with artificial intelligence, let's say machine learning type of software. And in this case, the collaboration with software faculty, with a software engineer is critical. Because if not, there's no way we can process data that just for you to take to have an idea. When we do this nanotomography, we can have in a single experiment a couple of terabytes of information. That's a lot. That's many hard drives. So really, we need to analyze this data with sophisticated program in collaboration with software engineers.
Tell us about the grant you recently received.
I'm very happy to say that very recently the European Research Council has awarded us an advanced grant just to work on that, just to work in the nanotomography of cement hydration for this 4D study, because at the end of the day, low carbon cement are known, but they are not in the market. Let's say very tiny fraction. And this is because this issue with the setting and hardening. And with the advanced grant and with this nanotomography, what we hope is to understand this bottleneck and to be able to accelerate it, to bring it to the market.
How will you define success in 5 years? What will that look like?
In my case, success, it will be defined if I understand, because I have a very clear challenge. There is an issue here, this bottleneck in cement hydration for low carbon cement, and we have two definitions. One is we have to understand the mechanism, but if we understand the mechanism and we cannot enhance it, so first is to understand it, and second is to use chemical to boost it. So there are two measures that will be to understand why this low carbon cement hydrate is lower, and then to use chemical with a lot of, let's say, detail, because the chemical cannot be expensive, cannot be harmful, has to be easy access. So not every chemical, but selected chemical that will enhance that. They are the two milestones that it will define if we have had this success or not in 5 years. The people say, but I am very reluctant to understand, I hope it will be true, in 2050 that we will have zero emission. I think that this is really challenging. I don't think this is attainable. But if we can decrease at least 50 or 80% in 2050, we know that statistics are complicated, because people can fabricate a statistic and can show this and that. But with a very good scientific background, if we can decrease by 60 or 80% the CO2 footprint of cement, this will be really a challenge and the success in the building industry.
Our proximity to leading research can support your innovation journey too. Join us and become a part of this vibrant community of innovators.